Alright, so in this video I'm gonna be explaining another important article about model editing. This paper, Aging with Grace, Lifelong Model Editing with Discrete Key-value Adapters. So it's a very simple approach for model editing that just bypasses one of the frozen one if based on some key. So we will talk about this key. What is this key? And this paper in 2023. So deployed language models decay over time to shifting inputs, changing user needs, or emergent world knowledge gaps. When such problems are identified, we want to make targeted edits while avoiding expensive retraining. However, current model editors, which modify such behaviors of pre-trained models, degrade model performance quickly across multiple sequential edits. So in their paper, they propose Grace, a lifelong model editing method which implements spot fixes on streaming errors of deployed model. For example, they are deploying different models of ChatGPT, but each time the world changes. I mean, even the news, the reality changes. So they cannot retrain everything from scratch. So what they can do is just make a fix for that. Let's call it bug. And so that's why they call it these spot fixes. And it writes new mapping into a pre-trained model's latent space, creating a discrete local code book of edits without altering model weights. This is the first method enabling thousands of sequential edits using only streaming errors. Our experience on T5, BERT, GPT models show great state-of-the-art performance in making and retaining edits while generalizing to unseen inputs. While retraining or fine-tuning can edit a model's prediction, doing this frequently is often too computationally expensive. So that's why there are many models to overcome this. For example, in continual learning, of course, model editing, as I said, is even much easier than continual learning, because you just freeze something and then you add an extra complexity to your model, and the post-edit and the pre-edit model have a low, the KL divergence between them is very small, so the prediction is stable. So they propose this Grace that has 3 contributions. They establish key metrics and comparisons for lifelong model editing. Lifelong is another name for continual learning. So they combine this idea with model editing. But continual learning is a very rigid area. You cannot do anything, and you should always keep all the weights in the memory, because you want to make this regularization. So when you want to reduce it, but for model editing, you don't even need this. And it doesn't have. Of course, there are some papers that write that it has a catastrophic forgetting problem. But there are methods that we can use to avoid catastrophic forgetting. So the same problem for continual learning, here we have the same problem. But there are also other problems. But the measures that we use for model editing There are different measures like stability, and we will go through them. So let F0 denote a model with frozen parameters that was pre-trained on dataset D train. We drop subscript, assume F consists of L layers. So this one computes hidden state at layer L. Grace. So a method for sequential editing a pre-trained model behave without altering its weight. So you see in this figure, it has some layers, and so each key has some neighborhood, and the model makes important errors that must be corrected in A. In B, you see that Grace makes edits by learning, caching, and selectively retrieving new transformation between layers. Because it's a rule-based, you will see how it is a kind of rule, a combination of rule and learning. Edits appear sporadically and require quick fixes, so Gray's codebooks are curated over long sequences of edits. This formula is the heart of this paper. It means that we have a deferral mechanism, some kind of election. Before editing, Gray's layers are empty. As editing progresses, Grace adds keys and adapts values and epsilon entries. Conceptually, inference at layer L with Grace entails a deferral decision, computing HL using a similarity search over Grace keys. So if the minimum of the distance between your edge and your keys is less than a threshold, epsilon, then by grace of God, by grace, you can, this is your model. Otherwise, you just give it the unedited model, FL, which is the unedited activation of the ELF layer. But note that HL-1 can be seen as a query to the codebook. So when I say what are the keys, these can be seen as a query, and Grace retrieves the value. For example, Grace of HL-1 at layer L-1 retrieves the value associated with its closest keys. Like in the picture, the closest keys, we associate for any query the closest keys, and through that, if the distance between our keys, our query and the keys is less than a threshold, then we use our model Grace. Otherwise, we just use the unedited model. And what is our unedited model? This is our our unedited model. This is our, let's call it our frozen model. That we haven't touched that. We haven't touched the weight of that, and we never touch the weight of that. We just say that this is what happens because it is good, because it looks that it is not buggy. It looks like it is a sample that works well on our model. If we give it to our model, it will produce a good prediction. So why should we change it? But if it is not a good sample, if it is a hard example, I'm talking in the framework of curriculum learning. In curriculum learning, it's like active learning. Curriculum learning, you pick the negative, hard examples that have low, very high uncertainty, and we want to make them more correct. Like like active learning, but active learning assumes that you have unlabeled data. You don't have access to labeled data. And so you see all of these curriculum learning, active learning, model editing, continual learning, all of these 4 branches are very closely related to each other. And if you want to do a good survey, you need to combine the ideas of these things, make tables so that you will see which framework has been implemented in which article. But the idea, as you see, is very simple. For each layer you do this. Once you get this, then you have a good, because you have keys and values, then you can generalize. You can generalize to unseen things, and we have generalizable edits are added over time. So it's like a stream of edits. Thousands of edits will come through time. And that's it. I mean, this is the heart of the problem, and the algorithm is pretty straightforward. But to compare each method, we measure 3 main metrics that align with prior work. Edit success, we check whether an edit has been successful using ES. And 2, test retention rate, we check how well an edited model retains its performance on its original testing date. And edit retention rate. These are metrics. So we have a grace key, for example, grace key is 7, and then we have the true label for that. And these are the edits.